Last week, we started our conversation on scientific measurements using scientific notation, standard notation, and we started to get into significant figures. We looked at the rules that said what makes a digit in a measurement significant. We didn't finish that conversation, so let's go ahead and do that now. Last week, we looked at this in-class worksheet where we started that conversation on significant figures, and we looked at what makes a digit significant. But we didn't quite get to is how do these significant figures in a measurement interact with each other when we're doing a calculation. So pull up that worksheet, let's go through these examples and then work through the practice problems on your own. Let's first start with the rules of adding and subtracting significant figures. Just like we had rules for scientific notation, we have rules for Sig Figs. And the reason we have these rules is because really when we look at a chemical problem, maybe you're in the lab synthesizing something or just running whatever type of experiment, a lot of the times these measurements that we take, maybe we may weigh something out on the balance or measure a volume, a lot of the times those different materials will interact. Maybe we're doing some chemical reaction. So how many digits at the end of our entire experiment do we trust? How many of those digits are significant? And that's where these rules come into play because, again, different instruments give us different amounts of precision. All right, so what's the rule? So for adding and subtracting, your answer has the same number of decimal places as the measurement with the fewest decimal places. This should make some sense in terms of a real-world example because, again, let's say you are a researcher and a cancer researcher and you have to deal with very teeny tiny amounts of chemicals, and you really need to trust that your measurements are precise and accurate. Well, you can really only trust the precision of the least precise instrument that you used. Think of that example of the balances. So the food balance that only gives you 2 digits versus the analytical balance that gives you 5. If you end up using the food balance, at the end of the day, you can only trust your number as much as you trusted it coming from that food balance. Let's look at a numerical example. Let's say we are adding the following 3 numbers together. 7.939 plus 6.26 plus 11.1. So we notice that we have 3 decimal places here, 2 decimal places here, and 1 decimal place here. Again, you can only trust your measurement as much as you trust the number with the least number of decimal places. So in this case, we're going to add these 3 numbers together. We're not going to round just yet. 25.299. So I want 1 place past the decimal. So I'm going to round so that I have just 1 place past the decimal. 9 is greater than 5, so 2 rounds up to 3. So this number becomes 25.3. Let's look at multiplying and dividing significant figures now. So whereas in addition and subtraction, you looked at the decimal place specifically, in multiplication and division, you're going to count the number of significant figures in your initial numbers. So the rule is round or add zeros to the calculated answer until you have the same number of Sig Figs as the measurement with the fewest Sig Figs. Whew, lots right there. So again, in the addition and subtraction rule, we look at the fewest number of decimal places. For multiplication and division, we look at the fewest number of Sig Figs. That's the difference between the two rules. Alrighty, so let's say we have this problem. We have 27.2 times 15.63 divided by 1.846. Alrighty, so when I plug this into my calculator, the answer in my calculator is 230.3011918. So that's what my calculator spits out. Now I need to round this final number to have the same number of Sig Figs as the one here with the fewest. So we see that this number has 3 Sig Figs, this has 4, and this has 4. So 3 is the fewest number one. So I'm going to round this number to 3 Sig Figs. All right? So that means, so this digit is significant, this one is significant, so is this one, because it's a trailing 0 in a decimal. Okay. So 1, 2, 3. Here we go. Those are my three digits that I need to have in my final answer. So I'm going to round. Does 0 go up or down because the number to the right is a 3? Or stay the same. So this stays the same, so our final answer is 230. We have 3 digits, just like we have 3 Sig Figs. Notice that the 0 is not significant here. That's okay. We have 3 Sig Figs, so we round to 3 places. Something I want to point out is that for this class, you only need to apply the rule for you only need to apply the Sig Fig rule at the very last step. So once you have your final answer. Before that, I want you to keep everything that's in your calculator in your calculator. I don't want you to round prematurely. So you see this in the notes. It says, do not round the number in your calculator until the very end. Again, you're only gonna apply the Sig Fig rule at the very last step when you have that final full number in your calculator. At this point, I recommend that you break from this video and work on these practice problems. So I want you to do parts C and D on that Sig Fig handout. Again, the answers are included on the back so that you can check your work through these, make sure you're doing it correctly. I will ask you to submit your work though. So again, take a pause here, look over your notes, work on parts C and D. We have looked at how measurements interact with each other, both in, for example, scientific notation, for how significant they are and how they carry over significance mathematically. Let's actually look at what makes a measurement and how do we go from one measurement to another.